Hello, I'm JW. This time we're going to have a look at LED tape. Now I've got a bit of it here. We're going to see how you can actually connect to this, but more importantly, how these things actually work and how you can actually wire these up to various different controllers and the sort of things you can do with it. Now, of course, you can buy this stuff and it usually comes on a roll, such as we've got here, and then there's usually some sort of controller goes with it and a power supply and whatever, and they're generally sold in the intent that you're just going to plug those things together and use it. But it's a lot more useful if you can obviously cut it into appropriate lengths, join it together in various ways, and obviously connect it to the appropriate controller, which may or may not be in the same place as the tape itself. So we're going to have a look at that and see how that can actually be wired together. Now, in terms of the tape itself, I've got a piece of it here. This is fairly generic, it's not branded in any particular fashion, but then 99% of this stuff isn't, even if you buy it from a overpriced UK supplier. It all probably comes from China and most likely the same factories anyway. So it's about 10mm wide. On the back here we've got a self-adhesive strip, so you just peel off this blue covering here, stick it down, and then on the top here we've got the LEDs themselves, these square objects here, and then we've got some resistors there. And this is the style you can actually cut at the points indicated here, so where those copper pieces are exposed you can cut it through there and obviously cut it to whatever length you would like. Now, in terms of this is being supplied, usually it comes with a few wires stuck on the end, but that's all very well if you just want to use the whole length. We'll see about connecting wires to this a bit later. Now, this particular tape is the kind which receives a fixed voltage at DC. This happens to be 12 volt tape. You can also get 24 volt tape, fairly commonly available. And the only criteria there is that the power supply you need to get to go with this obviously needs to match the tape. So this is 12 volt tape, you would need a 12 volt power supply. And of course, if you bought the 24 volt tape, you would need a 24 volt supply. So that's fairly obvious. Now, you could just connect the voltages to this directly, in which case it would just switch on and stay at whatever colour you want. And if it was a single colour tape, so the one that would say it was all red only, then obviously that's perfectly fine. But this is a multicolour one, as evidenced by the multiple connections it has. So generally you're going to want some kind of controller to go with it. Now, we've got an example here. Again, this is some fairly cheap generic thing. This only costs about £10 for the whole thing. And what you get is some sort of remote control here. This is a battery powered affair with a tab to pull out to activate the battery. This one's an infrared, meaning it sends out pulses of infrared light there, which have to be picked up by this thing. And if you point it at the camera, we should be able to actually see those. Can't see those with the naked eye, but most cameras can pick those up. So if you want to check if the control's actually working, just get your smartphone, point it at the camera there, and you should be able to see that flashing on and off. So anyway, a fairly generic item, and then this thing is what goes between the power supply and the tape. Now, this comes with this sort of connector thing on, and when you buy this tape, it actually comes with a similar sort of connector on with just pins that stab in there, and there's a little arrow to line it up. You can use that if you want to, but it's generally more reliable to actually solder these things directly, especially if it's going to be a permanent installation. So that's where the tape connects. This is just the sensor which picks up from the infrared control here. And then you're supposed to just plug in the supposed power supply you buy with this, one of those things that plugs in the wall and then just shoves in here. But again, it's far better just to solder the connection directly and use a wired-in power supply. And if we have a look at the top of this one, we can see here that the input is 12 volts to 24 volts, so this is fairly universal, either with 12 or 24 volt tape. And surprisingly enough, the output is exactly the same, because all these things do is take the voltage in, say at 12 volts, and then the output voltage is varied, and that's what adjusts the brightness of the LED strip. So the maximum output is whatever you put in. If you dim down the tape, obviously the voltage is lower. The only other things to consider with these is that the output current is going to be limited. In this case, it's 2 amps, and there's 4 channels, so you don't want to exceed 2 amps per channel, otherwise it will melt. And then the other thing, of course, is how many channels it's got. This particular one is designed for what's called RGBW, and it has 4 channels. That's red, green, blue and white. You can get these in other versions such as 3 channels, which is red, green and blue, and in theory single channels as well, which just has a single colour for the brightness. Now power supplies for these, you can get those plug-in things that go in the wall, which is a bit rubbish, or you can get the permanently wired-in things. Here's a typical example of that. For the demonstration here we're going to be using the bench power supply, and obviously we don't have to wire it in permanently here. And then the fourth component, which some people might consider optional, but it really isn't, is what you're actually going to stick this stuff into. Now, in theory, you can just peel this off here and stick this onto whatever surface you want. But the problem with that is that when LEDs are used, they get warm, or in the case of fairly high-powered ones, they actually get fairly hot. So if you just stick this onto the bottom of your, say, kitchen cabinet, then that heat is going to be pretty much concentrated in the LEDs, and the result is they're not going to last very long. So generally the better idea is to buy an appropriate channel made of aluminium for it to go into. Now here's an example. This is just a fairly rectangular and fairly generic item again. This is aluminium extrusion. The tape just fits down inside there. This is 10mm tape, and you see the channel is probably about 13 or so millimeters wide. Just fits in there, so you would stick this in there. Because this is aluminium, it's much better at removing the heat from those LEDs, so they run cooler overall, and of course last considerably longer. And the other thing that comes with this is this sort of plastic cover. So you put the tape in there, and then this cover just snaps in over the top, which obviously protects them from dust and dirt and whatever, and also sort of a diffusing effect in the case of this one, which is a fairly opaque material there. You can get this channel in a whole variety of different styles and types. So this just happens to be a rectangular version. It comes with little clips to secure it to a surface. You can get this in a variety of styles, including ones which you actually plaster into the wall. So you would fix that to the wall first, plasterer comes along and plaster it all in, and then you fit your LED tape in afterwards, so around, say, the top edge of a room or something like that. But pretty much essential to actually use this stuff, because otherwise, say, this is not going to last very long. It's going to overheat and fail fairly prematurely. This one is bare on the top, which is generally what you want to use with this sort of channel. There is a style which you can get which has a coating over the top, some kind of resin or other sort of gunge material over the top of that, which is more water resistant. That can be useful in some cases, but if you're going to use it with this channel, not really a whole lot of point for that. So that's the four things: power supply, which provides 12 or 24 volts, the tape itself, which obviously needs to be 12 or 24 volts, some kind of controller, and then the channel to actually put the tape into. Now in terms of connecting to the tape, it depends on the type of tape that you have got. Now the simplest style is just a single colour, and whatever colour you buy, that's the colour it is. So whether that's white, red, green, blue or whatever else, it's going to be that one forever. And at the end of the tape you'll have at least two contacts if it's a single colour, and obviously more for the various different ones. So if it's a single colour tape, at the end of the tape here you will have two copper pads, something like that. And in terms of the single colour, they will be marked, so one of them will be positive and the other one will be negative. And all you've got to do to power that is just apply 12 volts DC in there, or in some cases might be 24 volts DC, depending on which tape you've purchased. Now, the important thing here is to remember that this is DC and therefore the polarity does matter. Positive and negative often need to connect to the appropriate ones. LEDs do not generally like being connected in reverse. They might not be damaged, but if you put them the wrong way around with the voltage there, it's certainly possible to actually damage them, and of course then the whole strip is useless. So correct polarity and obviously the correct voltage, just a matter of identifying which is which. The tapes are generally printed with the positive and negative as appropriate, so not really any confusion in that regard. Now single colour tapes certainly have their uses, but of course they are only a single colour. So if you buy green tape, well, it's green and that's the end of the matter. But you can of course get other ones. The next one up is called RGB tape, and this has generally a single LED package on there, which has three individual LEDs inside, one of which is red, one green and one blue. And by varying the voltage to each of those, you can mix them together and make various different colours. So if you put, say, red and green on at the same time, you get a kind of yellow colour. And in theory, if you put all three on, you can get white, although the white from red, green and blue mixed together is not necessarily the kind of white you would necessarily want to use for normal illumination. And then that brings us on to the third type, which is RGBW, which has the red, green and blue elements, and additionally a single white element as well. and you can normally get that in cool white or warm white as required. So for the RGB tape, it'll have 4 pads on the end here, one of which will be for red, one of which is green, one of which is for blue, and then the final one, you might call that the sort of common. Virtually all of the tape, as it all comes from the same factories in China, has the common arranged as the positive, and therefore the red, green and blues are actually all negatives. And again, it's either the 12 volts DC or in some cases 24 volts DC. So for this style, you just connect the positive to the positive connection here. If you want to turn on the blue, you connect the negative to the blue one. If you want to turn the green on, you connect the negative to the green. And if you want to turn on the red, well, you connect the negative to the red. And if you connect to all 3 or any 2 of those, then obviously those will turn on as well. So this is where those little controllers come in. They just vary the voltage to each of the red, green and blue. Now it's important to remember that the common is positive, because on a lot of these, particularly with the wiring, you'll find that the common one is actually black, because they've used red, green and blue for the other 3, so you can't have a common that's red as well. So although this is normally black, it is actually positive, so don't go connecting negative to there, because again, if you connect this backwards, quite likely you're going to damage the strip beyond repair. And then the RGBW, which is red, green, blue and white, that has 5 connections on the end. Common is the same, so common there, and again that's generally positive for the common. And then for the other 4 you have red, green, blue, and then the 4th one is white. We'll just draw that in orange because reasons. Works exactly the same as the other one. It's positive for the common, and then all of these are negatives. And again, it's either 12 volts DC or 24 volts DC, depending on which tape you've purchased. So if you connect positive here and you connect negative to the white, then the white turns on. You connect it to the green one, the green turns on. If you connect it to the red and green at the same time, then that's going to be yellow, because red and green light added together makes yellow. And of course, there's other colours as well. Now the advantage of having 24 volt tape is to do with voltage drop. These things are fairly thin because it's just literally a very thin print, or not quite a print, but it's an incredibly thin trace on the tape there. So for high powered tape, 12 volts, there's going to be quite a lot of voltage drop along the tape, and that will show up as the end of the tape becoming dimmer the further away you get. If you get 24 volt tape, that will reduce that problem, because higher voltage means the current in the tape is considerably less. So double the voltage, half the current, so the effect is obviously lower. So if you're going to put very long lengths in, 24 volt tape is certainly an option, but either way the wiring up is exactly the same, no real difference with that. And the only other thing to consider in terms of the power supply, as well as obviously being the appropriate 12 or 24 volts to match the tape, the other thing to consider is the power output of that. Tape is generally rated in certainly watts per meter. The tape we have here is 12 watts per meter. So if you had, say, 3 meters of that, that would be 3 times 12, which would be 36 watts. And therefore, whatever power supply you've chosen, 12 or 24, it would need to supply at least 36 watts. And generally, want to go slightly over. So in the case of that, say a 40 watt power supply would be quite a nice thing to have there. And again, if you had the whole 5 meters of this on a single power supply, that would be 5 times 12, so that would be a 60 watt power supply. And of course, you have longer lengths or multiple lengths onto a single one. Again, you'll need to upsize that power supply as appropriate. If you don't, all that will happen is the power supply will get very hot. It'll overheat. If it's a good one, it may just shut down and then turn on again afterwards. It's cooled down. If it's some cheapo thing, it may just turn off and never turn on again, or possibly set on fire. So just make sure that the power output is absolutely minimum of what the tape requires, and in many cases, say, preferably a bit more. So in terms of connecting this stuff up, power supply of suitable voltage and power, we're saying it's 12 volts here, but it could be 24. 230 volts AC goes in over there, so we'll put that in as the blue and brown for the neutral and line there. Obviously you're going to have some kind of switch on that side so you can turn them on and off. Most of these controllers will remember the setting you had before, so if you set it to light pink and then you turn it off here, when you turn it on, and it should come back on the same colour. Even the cheap Generic Chinese ones will do that. Then you're going to need the power supply connecting to the controller, so 12 volts in this case, so it's going to be positive coming across to the appropriate terminal, and obviously the negative coming across as well. Black and red would be the sort of traditional colours for positive and negative, but again, you don't have to use those, just whatever cable you've got available. Just make sure the polarity is of course correct. And then it's a question of connecting the controller to the tape you've got. Now in the case of the tape we have here, which we'll look at later on, that is the red, green, blue, white version. So you're going to have 5 wires coming over for the red, green, blue, white, which will do orange, and then the common, which is generally black, but bearing in mind the common is positive, so don't go connect that to negative because that's an easy mistake to make. That's likely to cause things to be broken. And then that is basically your finished article. Now if you want to connect additional lengths of tape, you can just connect them to the end of this and have another length and another one here. But the problem with that is the voltage drops. So if you can, it's better to put an extra cable and say join them here. So you have another strip of tape, just join the same wires through. It doesn't actually matter. And if you're going to feed it all from one end, you could have say 3 blocks of tape there, each one driven from the same set of wiring. Bearing in mind even the thinnest wiring you're going to use, even say sort of 0.5mm squared, is still going to be hugely bigger than the tracks on the various bits of tape. So you can just extend these wires onto these ones, just use a connector or something to join them together somewhere appropriate. If you've got very long pieces of tape, then another option you can do is to put the supply in from both ends. So as well as putting it on here, if this was say a 10-metre length of tape or something right across a room or something, you can actually put a cable to this end, and you can also put another cable from here, so these will basically join off here, run a cable all the way to the other end of the tape, and then power it from that end as well. So again, that will reduce the voltage drop. So you could use, say, 1mm squared flex or something to go across there, and again you bring across the other 4 just the same way like that. There are devices you can get called amplifiers or repeaters for this stuff, which basically look like the controller, except they have the same number of inputs as outputs, and you just stick that on the end of the tape, put an extra power supply in at that point, and then you can drive another piece of tape. Yes, they do work, but not generally necessary if you can actually put in the cabling before the tape goes in. That's certainly a better solution because it keeps everything in one place. Cable's not going to fail, but those repeater amplifier things, of course, possibly could. Now, as well as driving the multicoloured tape like that, there is another thing you can do, particularly if you wanted a very high power output. What you could do, if you want to say red, green and blue, is to have 3 tapes, as we've got here, but have these single colours. So this could be the red tape here, this could be green tape, and of course, unsurprisingly enough, this would be the blue one. Although you could use any colours you want, you don't have to use the 3 that are provided. So red, green and blue, you can use the exact same controller, not a problem. What happens then is that you've got your red output coming controller, that only goes to the red tape in here. Green output, again, just goes to the green tape. And as you can probably guess, the blue output just goes to the blue tape. And then the common connection, which again is that positive, that would just loop to all of the positives on all 3 of the tapes like that. It'll work exactly the same. The benefit here is that you can generally have a much higher power, so in theoretically 3 times the power there. You could put these all on the same piece of aluminium track or whatever, get theoretically around 3 times the power, 3 times the light output. So there are options. It doesn't have to be all in the same tape. It'll work just fine whether it's 3 separate tapes or any combination of. And as a final point with this, you can also get other things such as little round like decking lights, which are also RGB. Usually it's the same kind of connection. There's 4 wires there, and guess what, it's the same as these 4 here. So you can use these and the same kind of power supplies for things like those. They just generally come with the wires already attached, so just a question of connecting to one end of that. Again, if you buy them, they generally come as a kit with various bits and pieces in, but you can also cut those up and modify them as appropriate. Now that will be the end of part 1. In part 2 we'll have a look at actually cutting this stuff up and soldering wires to it and actually seeing it working, so that will be in a separate part, as this particular video has gone on for long enough. Now the controller we saw earlier, that is obviously a very basic type, just has that infrared remote control, but you can get a whole range of different ones of those, including the so-called smart ones, which you can attach to apps in your phone and those spying talking boxes you can have installed in your home. So only difference there is it's just a question of buying the appropriate controller. In terms of wiring in, it's pretty much exactly the same. All of the smart functionality, whatever, is just within the controller, whether it's say voice activated or from an app or whatever else. It really doesn't make any difference to the actual wiring. But that is it for this video. Until next time, thanks for watching.